Okay, this time I think I actually am streaming. All right. I've done this once already. Oh, not that you guys care. Um, okay. So, here to give you some notes on rates and unit rates. Um, so here we go. I realized I also need some nice dark colors. Um, so I'm just looking at my color wheel here. Let's go with a dark blue. And then let's make this a darker orange. And this, I think the green's pretty, well, let's go with the darker green. There we go. That's enough to get me going. Um, Rates and unit rates. So a rate is a ratio of two quantities using different units. So my example would be 3 problems every 5 minutes. And so if we look at that, we've got a rate. But a unit rate is different because a unit rate compares a quantity to 1 unit of another quantity. So in this case, 3 problems per 5 minutes is not going to work. But if you divide 3 by 5, you get 0.6 problems, or 0.6 of a problem per minute. That would be a unit rate. Or you could have the same thing would be 3/5 of a problem per minute. Those would be the same. So speaking of the same is that we have what's known as equivalent rates. And equivalent rates have the same unit rate. So we see that these two are the same unit rate, just written differently, but we look at 3 problems per 5 minutes. Well, we could go 6 problems every 10 minutes, or we could go 9 problems every 15 minutes, or we could go 12 problems every 20 minutes, and so on and so forth. So they give us an example down here. And they say, hey, you pay $300 to $50 for every quarter ounce of gold. And so they give us the rate, and then they give us the unit rate of $1,400 per ounce. Now, the way that they did that is to take 350 and divide it by 1/4. But if you take 350 and divide it by 1/4, that's the same as multiplying by the reciprocal because we're doing keep, change, and flip. So keep the 350, change to multiplication, and then the reciprocal of 1/4 is 4. So 350 times 4 is apparently 1,400. And so again, algebraically, they have this down here that here we have A in red units and B in blue units, and red and blue aren't the same. And then, so they're different units. I just find that funny right now. And then A units, and then right here, B has to be 1 unit. Or they have the oh, I get what they're doing. They're actually having the fraction here. They're having the fraction of A divided by B red units compared to 1 unit. That's what they're doing. I see. All right. So a nutrition label shows that every quarter cup of tuna has 1/2 gram of fat. So how many grams of fat are there for every cup of tuna? So we've got 1/4 gram of fat for every, 1/2 gram of fat for every 1/4 cup of tuna. So we're going to perform keep, change, flip. So that's 1/2. And then we change the division to multiplication. And then we take the reciprocal of 1/4, which is 4/1. And so 1/2 times 4 is 2. So we have 2 grams of fat for every 1 cup tuna. So then they ask how many cups of tuna are there for every gram of fat. So we take 1/4 cup tuna, we take 1/2 gram fat, and we divide. So division again is keep, change, flip. So we're going to keep the 1/4. We're going to change to multiplication. Then we're going to change the 1/2 to its reciprocal, which is 2/1. So 1/4 times 2 is 1/2. So what we have is we have 1/2 cup tuna per 1 gram of fat. So here's a problem. Scientists estimates that a jet liquid of iron in the Earth's core travels 9 feet every every half hour. Wow. It's 4 o'clock in the morning, so I'm sorry, I'm misreading things. 9 feet every half hour. How far does liquid travel in 1 day? So we're looking at distance, and I'm going to make a table because I think that it makes more sense. Distance in feet compared with time in hours. And so we're looking at um, 9 feet every half hour. Now, it doesn't say to do this explicitly, but I'm going to go ahead and find my unit rate. So instead of having a half hour, I want 1 hour. And in order to then find this value for how far it travels in 1 hour, I'm going to take 1, divide it by 1/2, just like we did yesterday. That's using keep change flip. It's 1 times the reciprocal of 1/2 is 2. And so we have 2. That's our factor. We're then going to multiply 9 by 2, giving us 18. So we travel 18 feet per hour. Then tells us, hey, well, how much does the iron liquid travel in 1 day? Well, notice our table is in hours. So we're going to change hours when we need the number of hours in a day, which is 24. And so again, we're going to now look at this and go, hey, this is actually pretty simple because what would you multiply 1 by to get 24? Now I asked that question and I stop and I realize that some of us, when I say it's pretty simple, some of us might freak out and go, hey, that's not really simple after all. So I'm going to go back to just using my method. 24 divided by 1 is 24. And then we do 18 times 24. And 18 times 24, I do believe is 432. Don't be impressed. I just did this problem earlier. Yes, it's still 432. Nice thing about math is that these numbers don't change. So 432 feet in 1 day. All right, last problem. You hike up a mountain trail at a rate of 1/4 mile every 10 minutes. You hike 5 miles every 2 hours on the way down the trail. How much farther do you hike in 3 hours on the way down than 3 hours on the way up? So here's my plan, and there will be a step 4. Plan. Find unit rate going up. Find unit rate going down. Find distance for 3 miles. That's for both up and down. And then find the difference. And when we find a difference, remember that that's a subtraction problem. All right, so our work is cut out for us. So first of all, we'll work with up. Distance, and that's in miles. Now time. Time we want to be in hours because everything else is hours except for this one pesky unit right there of 10 minutes. So, real quick thinking this through on a clock. If you were to break the clock up into 10-minute sections, you would have 6 10-minute sections. And so therefore, 10 minutes is 1/6 of an hour. So we have 1/6 of an hour. We have 1/4 mile walked going up. We want the unit rate. So we want the time to be 1 hour. So what we're going to do then is we're going to go 1 divided by 6. 1 divided by 1/6. I got a little ahead of myself, sorry. 1 divided by 1/6. That's the same as 1 times 6 over 1, which is 6. And then we're going to go 1/4 times 6, which is 6 over 4. However, 2 goes into both these numbers because they're even, and so we now have 3/2 of a mile per hour. We're not done there, but we're going to slow our roll and just go back to it in a moment. Going to change over to distance here for up or down, sorry. We're going to go down. Again, we've got distance, got miles, we got time per hour. We're looking at 5 miles every 2 hours. So again, we'll do our little math here because we want to get a unit rate, so we want to change that to a 1. Admittedly, you can get to 3 hours in a different way, but like I said, I want my unit rates. I have reasons for that. So we go 1 divided by 2, that's 1/2. Then we take 5 times 1/2, and that's 5/2. So we climb 5/2 of a mile in 1 hour going down. Now I want you to stop and understand this. Going up is slower than going down. We can see that by our numbers. We only get 3/2 of a mile going up, whereas we get 5/2 of a mile going down. So going up is slower than going down, or going down is faster than going up. And this is where math puts a tangible quantity, a tangible description on something that otherwise would just be a vague notion. We all understand we walk up a mountain slower than we walk down the mountain. We've probably all gone to not Cass, wow, that's where I grew up. Uh, the park where the sledding hill is, not Ellis Sharp, but the other one. Yeah, you all have probably been to that sledding hill over at Cascades. There we go. In Cascades, you walk up the hill, you walk up slower, then you travel down. But this actually puts some quantity on it. It can tell you that we've got 3/2 miles per hour, and we've got 5/2 miles per hour. And so it gives us a way to compare the two and describe what's going on. Anyway, what we want now, we found the unit rates for both, so now we want to find the distance for 3 miles. So 3 miles here. So actually, I'm going to change the color here and go 3 miles here. So 3 miles here, we would do 3 divided by 1, which is 3. And then we can go 3/2 times 3, which is 9/2. So what we have then is we have 9/2 miles. Now, 9/2 is fine, but it's probably easier for us to think about this as 4.5 miles in 3 hours. Then down here, we've got 3 hours again. So we go 3 divided by 1, which is 3. And then we go 5/2 times 3, which is 15/2. Now again, 15/2 isn't a bad answer, but it's probably easier to subtract in a moment using 7.5 miles. So what we found is we found our unit rate up, we found our unit rate down, we then used those to find the distance for 3 miles, both up and down, and then we're going to find the difference between them. So here we go, finishing this off. We go 7.5 for the miles down, and then we go minus 4.5 for the miles up. 7.5 minus 4.5 is 3 miles. So the final capstone to this problem is since I said you earlier, I travel 3 more miles down in 3 hours than going up. All right, so there's your notes on rates and unit rates. Hope this helps.